Hello and welcome. Thank you for joining us for part one of our WATERJet water-only webinar series. My name is Benji Macera. I'm the product manager here at WARDJet, and I'm happy to have with me today Terry Craig, who's a management consultant in business development for Zote Foams, one of the leading manufacturers of foams and other materials, and Jeff Day and Johnny Stamberg, two of our applications engineers here at WARDJet. We're going to talk about a number of different topics today, including looking at some systems. But what I wanted to start on was talk about what makes WARDJet different when processing soft good cutting and some of the benefits of using WARDJet systems for soft goods processing. To start off, WARDJet is the only manufacturer that does offer multiple systems that are specifically designed with soft goods cutting in mind. And we'll show you some of those features when we walk through the machines today of how that differentiates us from other manufacturers. One of those big differentiations is the multiple options we have for soft goods material handling, again, which Jeff will cover some of those options as we talk through one of our J series machines today. But even more so than just material handling in the machine is we do have multiple series that cover soft goods processing with a number of different speeds and accelerations, as well as workflows that really cater to soft goods processing in general. As you can see at the bottom, just looking at the speeds, we have our Z series, which runs up to 500 inches a minute, up to the X series and the J series, and all the way up to our L series, which is our fastest water jet, running up to 7,000 inches per minute. So whatever your material, whatever your layout, or the job that you need, WARDJet does have a solution that is tailored for that application. So moving on, I wanted to talk about just in general some of the benefits of WARDJet water jets for soft good processing. A number of different ones, but we'll walk through them here. First is going to be flexibility. One of the biggest things that separates WATERJet from some of the other processes for soft goods cutting, such as dyes and things like that, is the ability to quickly change between part profiles without having to spend time changing out dyes or do a different setup. The tool is the same no matter which program you run. Only thing that's going to change is the geometry and then the time spent for cutting that material. So say if you have multiple nests or you've got a little bit of material left and you wanted to get a few parts out of that, you can quickly program something up or pull up a previously existing program, load up the program, run it, and then switch back to your normal processes without taking time to change the dyes, or if, God forbid, say the geometry changes by a slight bit, you don't have to send that die out and get a whole new die to change that. You're just altering the code and going right back into production. Another big advantage of WARDJet water jets for soft good processing is high-speed motion. Now, that does mean the overall speed of the machine, but even more importantly is the acceleration of the machine. So if you have a very large nest, say 100 pieces, and getting from cut to cut takes you 1 second with a slower machine, but you can cut that down to half a second with a machine that accelerates and decelerates very quickly, getting from part to part. Now your overall processing time is going to decrease, and therefore more production, better cost per part. In a game like water only processing, if you've got a very small part, your profit margin and your cost on that part might be very small. So the ability to crank out as many parts as possible and then increase throughput is going to be very, very important. One of the biggest things we focus on here at WARDJet and what separates us is the addition of multiple heads to a system. We can take a very common layout, but we can add 4 heads, 8 heads, up to 16 heads that we've done on systems before. And for smaller geometries, you can see how that would really increase throughput. So a normal nest may take you, or a normal part may take you only 30 seconds to process that part. But if you multiply that part by 4, 8, 16 times, now that same 30 seconds, you've now increased your production exponentially. So multiple heads is really, really key benefit of using WARDJet water jets. Another is the addition of 5-axis capabilities. So other processes such as die cutting, things like that, you have one 2D geometry that you can stamp down and create. With a water jet, we can create these more complex shapes. So top geometries that are different than lower, bevel cuts on the side, you name it, we can really produce it. And there's a number of different videos we have of us out there doing some complex 5-axis cutting in foams. So this really does separate from other processes. Material stacking is also very important. Similar to the multiple heads, if you've got a thinner material and you run one program, but you've got, say, 3, 4, 6 pieces of material stacked on top of one another, in the same way that multiple heads are going to increase your production, material stacking would also increase your production as well. With the stream being as powerful as it is, depending on the material, and clearly you'll have to do some test cuts to see what works right for you, but you can stack multiple materials. That way you're increasing your throughput as well. The last is no deformation. So WATERJet in general, it's a non-contact form of cutting. So we never actually put any sort of stress on the material downward or to the side. And the benefit of this is going to be when you're cutting thicker material, as well as when you are stacking material, your geometries between the first piece and the last piece will be the same, because you won't have any sort of pinching or differences in geometry as you depress the material in order to cut through it. So WATERJet is really ideal for that, because your top geometry can be the same as your bottom geometry. So those are a few of the benefits of cutting with a WATERJet for soft good processing. So now I'd like to toss it over to Terry Craig to talk about Zotefoams a little bit and what makes their material and their process so different from anybody else in the industry.
Hello, my name is Terry Craig, and I've been asked to speak with you about a family of materials that is produced by a unique process. Zotefoams offers a range of high-performance, lightweight, cross-linked polyolefin block foams known as azote that are among the purest, most consistent, and technically advanced cellular materials on the market. But first, a bit about my credentials. I've been in the foam fabrication industry for over 35 years with direct experience in automotive, aerospace, mass transit, medical, defense, electronics, and of course, product protection. My career has spanned operational and executive roles in quality assurance, manufacturing, product engineering, design, and business development. I've worked with Zotefoams material since the early 90s, and today I want to share some of the advantage of their products from a fabricator's perspective and how these advantages can help you to grow your business. It all starts with an understanding of Zotefoams' unique process. Most cross-linked polyethylene and copolymer block foams rely on chemical blowing agents to create a cellular matrix, and those blowing agents can introduce volatile organic compounds, which become latent and residual in the foam material. Zotefoams' azote materials do not use chemical blowing agents. Instead, use high-purity nitrogen, which is among the most common elements in the universe and is generally considered inert. In fact, it makes up approximately 78% of the air we breathe. So how does Zotefoams produce foam from nitrogen? Well, it involves a unique three-stage process. Stage 1 is extrusion and cross-linking, where polymer and additives such as colorants, fire retardants, or conductive agents are extruded into a solid, continuous plate, which is cross-linked, cooled, then cut into slabs. Stage 2 is nitrogen saturation, and this is where the science begins. Slabs are heated above melting point and infused with high-pressure nitrogen gas. Rapid depressurization at a controlled rate causes nucleation of the cellular structure within the slab, and subsequent cooling while under pressure locks in the nitrogen. Temperatures in the autoclave reach above 250 C or 480 F, and pressure can exceed 670 bar or 10,000 psi. To put that in perspective, that's the pressure of water more than 4 miles beneath the surface of the ocean. Stage 3 is expansion. By heating the slabs under moderate pressure and then reducing the pressure, the locked-in nitrogen is allowed to expand. Important to note is in this process, expansion is unconstrained and uniform in each direction. There's no physical mold or platen that can cause densification along sidewalls or from top to bottom within the block. This is a very important distinction which contributes to several performance characteristics, which I will describe in detail. How does this unique process benefit the use of the material, and specifically its fabrication? First, from its purity. Low outgassing, low VOCs, no residual blowing agent, and low fogging means you have the ability to provide protection of devices and instrumentation that contains sensitive optics, lenses, and electronic circuits without concern for fogging or staining. coupled with very little odor, makes these materials perfect for sealed bag and case products such as supplied in medical kitting, product protection, and case inserts. It also enables you to meet stringent interior emissions requirements for human occupancy applications such as in automotive, aviation, and mass transit. It is also excellent for direct skin contact in medical and sports products, meeting international standards for skin irritation, sensitivity, and cytotoxicity, and its closed cell structure prevents moisture and fluid ingress while suppressing bacterial growth. Purity also produces foams with the whitest whites, the deepest blacks, and vibrant colors, all providing unparalleled choice to suit the end-use product. Consistency. The Zotefoams process enables control of the cell size. Combined with unconstrained expansion, the cell structure is considered isotropic, meaning predictable performance no matter what direction a stress or strain force is applied from. There's no machine direction cellular orientation, no elongated cell structure, and no density stratification through the block. From top to bottom, across the full width and length, the material will process and behave the same. For applications involving comfort or protection, this means product performance will be uniform, consistent, and predictable no matter the orientation that the material is used in. Unconstrained expansion also means low built-in stress, which reduces the potential for distortion during processing and in the final product. Have you ever split a bun into sheets and then discovered that the overall dimensions change or the squareness of the sheet becomes distorted? Zotefoams materials are dimensionally stable as received. Important to throughput. It does not need to be split into sheets, then stored anywhere from 24 to 72 hours or more to allow the material to relax and normalize. And unlike chemically blown materials, Zotefoams products do not need to be pre-split to allow outgas of any residual blowing agent. Now let's talk about performance in processing. Uniformity and controlled cell size produces consistent, finished product with clean, smooth edges and with surfaces that are more resistant to marring and scuffing than most chemically blown materials. This is often important in case inserts, display packaging, medical, and sports components. You can achieve high quality, intricate, and precise geometry with unsurpassed surface appearance, be it through CNC machining, WATERJET cutting, die cutting, hot wire or abrasive wire profiling, or virtually any manner of fabrication technique. Zotefoams materials are also easily thermoformed, heat laminated and bonded with throughput speeds and yield factors that are among the best in the industry. Often, lower density materials can outperform higher density competitive product while providing savings in weight and in overall component cost. We've talked about the material, now let's talk about Zotefoams, the company. They offer the widest range of block materials on the market, including low density and high density cross-linked polyethylenes, VAs and EVs, along with fire retardant, conductive, static dissipative versions, and specialty polymers including nylon, PVDF, and TPE. Zotefoams has the ability to tailor the dimensions of their products to achieve optimum dimensional yields on high volume applications. This reduces material content, increases production throughput, and importantly, reduces waste. Supported by decades of technical experience and documentation geared specifically for regulated industries, including automotive, medical, defense, and transportation, Zotefoams acts as an extension of your sales and technical departments. Being onshore produced with a controlled distribution network, the logistics benefit include LTL shipments, no upfront costs associated with placement of offshore container load orders, reduced inventory, and importantly, increased turns, putting cash flow back in your wallet. To summarize, unique process produces unique materials, pure, lightweight, consistent, and visually appealing materials that process with ease and speed, and in combination with product range, technical support, and onshore logistics, enables fabricators to grow their business in virtually every major market and application. To learn more about the extensive benefits of specifying and processing Zotefoams products, please connect with us through zotefoams.com. We will be very pleased to answer any questions you may have. Thank you for your time today.
Thank you again for joining us for our J-Series water-only webinar. I'm Jeff Day, one of the application specialists here, and in front of me, Johnny Stamper, one of our other application specialists. So this is our J106, it's a 6-foot by 10-foot cutting area, And as with all things WARDJet, this can be customized to suit your application, whether you need a larger cutting envelope, whether you need longer offloading, onloading tables. This machine has a 10-foot loading area, 10-foot cutting area, 10-foot offloading table, but these can be stretched or shrunk depending on your application. We can also change the material for the belt. This is a one continuous stainless steel belt. You can have 3 separate belts, and the onloading and offloading belts could be different materials depending on your application. So with that, we'll go ahead and zoom in on some of the other features on this machine and see what really sets this apart as a water-only cutting system. So down here at this end of the machine, this would typically be where you would feed your material into the system. That's one of the nice things about the J series is you can either use it to cut planks of material like we have loaded on here that we'll be cutting initially, or you can cut rolls of material. So typically if you're going to be using a plank, you won't need the pinch feed roller that's shown here, but when we do the roll, that pinch feed roller will come down, pinch the material, and help pull it into our cutting area. So from a safety aspect, we have this surround around the cutting area and around the machine to keep your people safe. The doors are interlocked, so if anybody tries to enter the cutting area while it's cutting, they open that door, everything's going to be put into e-stop. Another safety feature is this cover back here, where if you're running the chain backwards and material starts to go under this cover here, then this will flip up and also put the machine into e-stop. So we've really looked at the safety aspects of working around a high-speed machine. Also down at this end, we have this control box here, which has a few different features. And this box, there's 4 of these around the machine. So one of the things you can do here is adjust how far down that pinch feed roller is going to come depending on the thickness of your material. So I have a button here that I can use to raise or lower that pinch feed roller depending on the thickness that I'm using. And then you've got a switch here that actually brings the pinch feed roller down to that height. Other things you can do back here, you can load your material. So if I press load material, it'll advance the material until it hits a photo eye at the front of your cutting zone, so you're at your 0, point on your table. You can also start and stop programs from these boxes. So if you're back here doing something and something goes on with the machine, or you just want to start your program, you can start and stop programs from here. And then you can also advance your chain forward or back with here. And then there's also an e-stop button. So there are 4 of these control pedestals around the machine. Okay, so a couple other key features at this end of the system that we can take a look at. First of all, over on this side, we have this guide here for the chain, and there's a corresponding guide at the other end of the system. So this keeps the chain tracking nice and straight, and this is important because if you're doing, say, a long part that's actually longer than the cutting envelope and you want to index your chain to continue that cut, this will keep that chain so it's tracking nice and straight. Another thing is over on the other side here, we have a material guide. So whether you're loading roll of material or board material, you can just butt that up against that guide, and that'll keep that nice and square going into your cutting area. And there's a corresponding guide like this in the cutting envelope to keep everything squared up. Okay, over here on this side of the machine gives us a good view of the construction of the tank. First of all, you can see the slope bottom design to the tank. So all your cutting water is going to drain to the middle of the tank here and then flow out of this opening here. Also, you can see a bit of the stainless steel floor inside the tank, which provides for a very long-lasting system. And then also there are washdown bars inside here, so we can pump some of this water back into the tank and use that to wash any residual material out into this area here. So outside the tank, we've got our sump tank here. So this has an expanded mesh screen to catch your larger pieces of material coming out of the tank. And then down in the bottom there, your sump tray, you can either put a sump pump in there to pump your water to drain. You might want to pump through a sock filter to get any additional residue out of the water before it goes to drain. Or you can also pump to one of our paper bed filters to help get that out of your water before it goes to drain.
I want to show you guys our optional paper bed filter that is placed between the water jet and your drain to get the heavy sediment out of your water before it goes to drain. The wastewater from the water jet is pumped over top of a micron paper that collects all the heavy sediment before the water passes through. As the sediment builds up on the paper is automatically advanced out the end and into a bin for disposal. The clean water then can go to drain for a environmental friendly disposal. The drive system on this machine is a helical rack and pinion that's been armalloy coated for rust and corrosion protection. Now we're going to do some test cuts. The new aluminum crossbeam comes in at 159 pounds, which is 70% lighter than the previous steel crossbeam. Between the rack and pinion drive and the lighter crossbeam, it allows us to reach speeds of 2,500 inches per minute at up to 80 inches per second squared of acceleration. The dual cutting heads have programmable Z and Y axis, which allows us for automatic head spacing, automatic leveling, and mirror cutting. This machine is also 5-axis capable with the new Apex 60 cutting head.
Thank you for joining us today for our J-Series presentation. We hope you enjoyed it. And here's just a small sampling of what we cut with about 10 minutes worth of cutting today on this machine. So as you can see, highly productive machine. And if you're interested in learning more about how the J-Series can bring this sort of productivity to your company, please feel free to contact us and we'll send it back for questions and answers now.
All right, thanks again for joining us. This is Benji Macera again. Go through a few questions and answers here. So I've got a few questions that are lined up here for applications focus. So Jeff, I'll refer these to you. So we mentioned in the beginning of the webinar the advantage of stacking material when water only cutting. What are some of the limits or some of the things to consider when you're trying to stack material?
Great question. First thing, of course, is the clearance between the cutting head and the table. Standard on all of our machines is 12 inches of clearance, although that can be increased. The other thing to look at is density of the material. So denser material, thicker material, you're not going to be able to do as many layers. You might have a 2-pound foam 1 inch thick, and you might be able to stack that 10 inches thick and cut it just fine. If it's a 9-pound foam, you might only be able to do a couple inches or 2 1-inch layers or 3 1-inch layers. And of course, also coming into play there is the size of your pump and number of cutting heads and the orifice and the desired edge quality. If it's a part that's going inside a returnable dunnage container and the edge is never going to be visible, might just be fine if it's a bit rougher. If it's a visible edge, then you might just want to do one layer for a smoother edge. So certainly a lot of factors that go into play there, and that's why we'll generally do large number of test cuts for water-only customers where they'll send us a palette of various materials and densities, and we'll run through it with different orifices and layers, and they can determine what's best for their situation.
Excellent. Now, you did mention some of the different speeds with some of the different cuts and the quality on there. What kind of what's the range of speeds that you could expect to cut with when doing some sort of a foam or something like that?
9-pound foam, for example, a couple inches thick, you might be at 50 inches a minute, whereas the other end of the spectrum, 2-pound foam, you might be able to max out the velocity of the machine and cut it at 2,000 or 2,500 inches a minute. And again, the orifice size is going to come into play there. So whether it's a 14 thousandths, 10 thousandths, 5 thousandths orifice, but generally those light 2-pound, 4-pound foams, you can almost run full speed on the machine on those materials.
Nice. We got a question here. I'll direct this to Zote foams. I know Terry mentioned in the video some of the uses for it, but what are the most common uses for that azote material compared to some of the other materials that Zote foams creates?
Yeah, this is Dan Catliner from Zote Foams. Yeah, my pleasure. We're a very diverse company with regard to the applications. Foam is close to everywhere, but the majority of the concentration of our market segments would be automotive, packaging. And when I refer to packaging, it could be general, it could be case insert, tool control. So we're in a variety, pretty expansive sections of the packaging segment: health and beauty, medical, sports and leisure, construction, military, government, and finally aviation applications.
Gotcha. Excellent. So pretty much everywhere.
Yeah, it's quite a bit, and it's one of those things, they're never all green within the same fiscal year, but that diversity helps us, and sometimes when some of the other markets are soft.
Oh, excellent. Back to an application question here. So, Jeff, are there any certain best practices when you're trying to program water-only parts in the way to get either more out of your material or a faster cut? Oh, Jeff, I don't know if I'm hearing you there if you're talking.
I'm sorry. Are you
There we
seeing my nested material okay?
Yeah, just fine.
All right, good. So yes, nesting, of course, is a huge thing. Being able to put parts within parts is big cost reducer. Common line cutting is a big thing with water only cutting, where if you have a straight edge, you can use one cut, go down the middle, save a lot of time there. If you have cuts that you can't do common line cutting at, you can look at doing chain cutting, where you use one pierce and might cut the outside of these 3 rings with one pierce. So things like that are going to help your cycle time. They're also going to help the life of your high pressure components, especially things like the needle and seat in your cutting head. So inside your cutting head, you have this called the needle and seat here, which keep the high pressure water from going through the cutting head when you're not cutting. Water only cutting, if you're doing thousands of cycles per hour, there's a lot of wear and tear on this. This needle can heat up. We have a specially coated needle for water only applications that can reduce the incidence of this sticking open. So anything you can do to reduce those on-off cycles is going to extend the life of this needle and seat and all your other high pressure components.
Oh, excellent. I also have another question that just came through here. Talking about life and performance of the machine is, do you recommend diamond orifice over sapphires, and how does this affect the quality of the cut and the life or performance of the machine?
Yeah, diamonds are the way to go, certainly. Once you switch to diamond, you'll never want to go back. Sapphires, you could get anywhere from 0 to 40 hours out of one, whereas a diamond, they're guaranteed to be at least 600 hours. And so it's great as you can put it in and forget about it for several months. We always recommend the use of a final filter like this before your orifice. Can even if you're using sapphires, it's going to help the life of that orifice because it's going to catch any debris that might come down the line. Yes, sapphire is going to be a bit cheaper than diamonds, but if you look at it on a per hour basis, it's going to be a lot cheaper to go with the diamond. It does give you better cut quality, especially in water only cutting. And the maintenance time to change out the diamond once every 600 hours is certainly a lot less than doing your sapphire once every week or two. And if you have a machine that's got 4 or 8 heads and you've got 8 sapphires on there and they're each failing a different number of hours, then you're kind of always chasing your tail. Whereas the diamonds, you can put them in and again, forget them for several months. So once you switch to a diamond, as I said, you'll never want to go back.
Excellent. I'd like to direct this next question to Richard that we have on the line. Richard Ward with WARDJet here. Someone's asking, what pumps do we like to pair with our machines? They asked if we use KMT. I know that we don't currently use KMT, but if you want to speak a little bit about the pumps that we offer.
Yeah, we typically use intensifier pumps. We have found, especially with water only, where you're going to be switching between maybe 1 head, 2 heads, multiple heads, maybe 1 pump running multiple heads on multiple different machines, all simultaneously with 1 machine switching off and another one switching on. That intensifiers definitely gives the best results for that. As far as brands, we typically use Hypertherm. If a customer has already got pumps that they are accustomed to, they're welcome to purchase whatever pump they're familiar with, and we'll connect it up, or even a used pump. So our focus is with building the best machines and allowing people to have a say on their pumps, but we obviously primarily supply Hypertherm. We're very happy with the way that they work and service and support and cost of parts, and they've been a good partner for many years.
Excellent. I'll take this last question here. So Stephen asked, mentioning about the different materials and the cutting speeds and trying to find the best setup on, test cuts, things like that. Asked if that consultation information is charged or if it's part of the sales service. Typically, those are included. When you start down the, if you're thinking of going towards WaterJet in a process, maybe replace an existing process. If you talk to your salesperson, we're happy to do test cuts for you. So send your material out to us. Jeff will typically be the one doing those test cuts. Go through, take some feeds, samples on those, send pictures. We'll do live video for you, videotape the test cut process, and then send that back, and you can decide really which finish and which speed works best for your process. And then we're happy to do time studies back and forth to see if going to a J series or something with a higher automation to it will fit into your process or reduce your overall cycle time. And then even do some analysis to say, right now you're spending essentially this much per part when you factor in time, labor, in your current process. But if you were to switch over to say a J series, we could reduce your overall per part cost by going this route. So we're happy to do that as well. If you have something down the line, even if you own the machine and you're trying something new, we're happy to help you out as well. So last question here. So Marcos asked if the machines now are modeled on the Axis CNC routers. I can also answer that one as well. So we are owned by, we're all WARDJet and Axis routers. Our parent, our parent company is AAG, so AAG Cutting Solutions. So while we are related and we work with them, clearly every day, our current designs are not modeled on those that are currently out on the CNC routers. We do, WARDJet was, a lot of these designs have been around for very many years before being acquired by AAG. But we've, worked for years on these designs and coming up with the best made WaterJets that are out there. But clearly we do work with Axis all the time and share resources and engineering as well. So some of the things that you'll see coming out will be shared across the two different platforms as well. So. Well, I'm not seeing any more questions come through. So, panelists, unless there's anything else you wanted to make sure that we mentioned, we'll go ahead and conclude this webinar for today. But I do want to say thanks again for everybody for coming out and taking time to watch this and ask questions and get engaged. We do have a part 2 of this webinar coming up. That'll actually be next week, next Thursday. We'll send out invites to that as well. We'll cover a little bit more about some of the different workflows in water only cutting and go over another system that we have, which is one of our X series with an over under shuttle table. And you can compare from the J series how that may be different in your workflow and really which one would be right for you as well. So again, thank you everyone for your time, and we'll hopefully see you next time.
Well, thanks, Benji.
Thanks everyone.
Yeah, thank you.